In this part, I'm going to talk about the OpenFlow. So OpenFlow is a protocol which enable like a programmable networks by allowing researchers to control flow tables and switches, separating the experimental and production traffic. So now I'm gonna explore it in more clear way. So as I have mentioned in the origin of SDN, so in OpenFlow was firstly uh, introduced in 2008 as an SDN architecture. So let's see what is OpenFlow. So this is the OpenFlow switch. Here you can see this is the OpenFlow switch, and in OpenFlow switch there is two different parts. First one is software part, and second one is hardware part. So in two this different part, there is this is the actually OpenFlow switch, and OpenFlow switch contains three parts actually: first, second, and third. So first one is hardware. And hardware is they have flow table. So in flow table, it is used to perform packet lookups and forwarding, and it's responsible for packet forwarding based on the entries in the flow table. And then we have the secure channel, which is in software part. So this one connects the switch to the remote controller. You can see here is a controller. So this controller is connected to the OpenFlow switch using the secure channel with the secure channel. So through this channel, controller can add, update, and delete, and like delete the flow entries in the switch flow table. And then the third part is OpenFlow protocol, which is implemented using secure sockets layer or transport layers security, TLS or SSL. And it is like the authenticated communication between switch and the controller. So using this OpenFlow protocol, controller talk to the OpenFlow switch in secure channel. So here is an example of OpenFlow enables commercial switches and routers. So first we can see these are OpenFlow enabled switches and routers. These are OpenFlow enabled switches and routers. So all of the devices have a flow table, a secure channel, and they are connected to the controller using OpenFlow protocol. And controller, you can see the central controller, it communicates with these switches, routers using the OpenFlow protocol. So all of the flow tables in the network are managed by single central controller, and then controller can add, modify, delete flow to the flow tables as I have mentioned before. And then when they introduce the OpenFlow, the researchers aim is to run experiment. So when running experiment, the two requirements, the main requirements is like isolation of traffic. One is experimental traffic, one is production traffic. So to gain the trust of network administrators, is essential to keep experimental traffic, I mean the data used in experiments, separate from the production traffic, which is the regular data used by the network. And the two methods used, experimental and traffic and production traffic, for doing this there is another two method. One is called fourth action and another is called separate VLANs. So let's make it clear. We just keep the two methods, fourth action, the separate VLANs. So in fourth action, this is a method like it's like involve adding a new action to the flow table of the OpenFlow switch and forward the pipeline. The new action would allow packets to be forwarded through the switch's normal processing pipeline, and it ensures the production's traffic is processed in the standard way, while experimental traffic can be handled separately by the flow table. And then we have the separate VLAN methods. So in separate VLAN method involves creating different set of VLANs, which is virtual local area networks, for experimental and production traffic. Production traffic is assigned to one set of VLANs, and experimental traffic is assigned to another set of VLANs. So this ensures that experimental traffic does not interfere with the production traffic. So this is the end of the OpenFlow.